So as we read this, it says Jack and Jill are walking back home from the bus stop, which is 30 yards away from their house. So I'm going to underline that. I want you guys to do the same. Just underline that it's 30 yards away from their house. They walk at the same rate, which is 4 yards for every 3 seconds. 4 yards every 3 seconds. Okay? So now, 4 yards every 3 seconds is the rate that they're traveling. And so the first graph here, if you graph the time and the distance, you'll get this graph, which is y equals 4/3 x. Because the x-axis represents the time that they're traveling, and the y-axis represents the distance. So x-axis is time, y-axis is distance. But now they say consider the two graphs. So the second graph, they are 30 yards away, because that's where the bus stop is, and they're walking home. And so when they get home, they are 0 yards away from their house. It looks like it takes about 22.5 seconds for that. So the second graph is walking home from the bus stop. Again, we have the time spent in the x-axis and the distance traveling. Now, question 1 says, analyze the graph of Jack and Jill walking home from the bus stop. Does this situation represent a proportional or non-proportional relationship? Well, the answer is it's non-proportional. And one thing I said, if it's a straight line, that's a clue that it's proportional, and that's true. But it also has to go through the origin. So it's non-proportional because it does not go through the origin. Okay? So this isn't going through the origin, right? The origin, if you remember, the origin is 0, 0. And so because that line does not go through the point 0, 0, then it's non-proportional. It has a constant rate of proportionality to somewhat because the change is the same all the time. But it has an initial value of 30, so the equation will look different, as you guys will find out. So it's not a constant proportional relationship because we have to add 30. Okay? All right? So now the next question is this line positive or negative? Explain how. Well, it's a negative because we're going to go down 4. So write this down. Go down 4 over 3. So when we look at the graph, if I start here, I'm going to go down 4 units, like to 26, and then over about 3. So I'm going to go down and over 3, down, over 3, and that's how you form the graph. Now, what that means is that my equation is really going to be y equals negative 4/3 x. And then our initial value is 30, so we'd have to say plus 30. So remember that the y-intercept is what we would consider an initial value. We're starting at 30 yards away. I misspelled initial, but that's okay. That's the initial value. This is the rate of change. And we sometimes call that, or you'll begin to call that, slope. So because it has a negative number, then we would say it has a negative slope. One last clue is that it goes downhill. So when you look at this thing, as you read it from left to right, the graph goes downhill. Okay? So when I look at this graph, as I read it from left to right, it's going downhill. Now remember, whatever I write down, I'm expecting you guys to write down. Positive slope goes uphill. So this is a negative slope. And this is a positive slope. Okay? So let me put that on the screen so you can write it down. So it goes downhill, so it's a negative slope. Our equation for that line is y equals negative 4/3 x plus 30. Now I just gave that to you, but we're gonna derive that. We're gonna draw that conclusion all by ourselves. Okay. All right. So we're gonna compare and contrast the rate of change in the slope of each line. So what we're gonna do is we're gonna trace using patty paper. Okay. So it's asking us to trace the line and use a right triangle that represents the rate of change or slope from walking from the bus stop. So what I'm going to do is I'm going to take this paper. This is my slope of the original graph, and they want me to draw a triangle. So what I'm going to do is this is the triangle that represents their journey. They're walking. And if I were to guess, I would say it'd probably take about 22.5 seconds to travel 30 yards. So the triangle represents the 30 yards that they travel versus the 22.5 seconds for time. And this is a distance. Okay, so I just traced that. So now that I've traced that, I'm going to compare that to this graph. Now I want to show you something that's interesting. If I flip this over like this, what do you notice? It's the exact same. So the ratios are the same, but in other words, you have 22.5 versus 30, but now it's like the opposite, right? Does that make sense? It's like the opposite. So one thing you could do, and this is not the formal definition, but you could think of a negative slope as being like the opposite slope. Okay? So when we compare these two, when we look at these and we compare these two, the question that they asked us was, use patty paper and trace and create the right triangle that represents the rate of change or slope from walking to the bus graph. Then next it says place the patty paper, so we did that. Then it says place the patty paper on the walking home from the bus stop. How can you transform the right triangle that you drew from the walking to the bus graph to the walking home graph? So how would you translate that? How would, not translate, but I mean, how would you, what did I do? So I'm going to do it, and then you tell me what I'm doing. So this is the original graph. To get it to map on top of the other one, I had to flip it over like this. That's a geometric thing we're doing. Can anybody remember what that is when you do this? Okay, I'm going to give you a couple seconds to think about that. Okay, so then let me state the question. It says, place your patty paper on the walking home from the bus stop graph. How can you transform the right triangle you drew from the walking to the bus graph to the walking home bus graph? So in other words, what geometric or mathematical thing did I do to get that done? So then what we did is we reflected. horizontally. So we just reflected it. So when I take this, and I just do this and I flip it over this way, I'm reflecting it horizontally. That's it. It's a reflection horizontally. Okay? So we reflected the unit rate horizontally. Next it says the unit rate remains constant between any 2 points on the line. Right? So, oh, I'm sorry, I should probably read the question. Slide the right triangle along the line of the walking home of the bus stop. What did you notice? So if I take this, in other words, if I take this and it's reflected and I slide this along, what happens? Yeah, it stays on the line. It has a similar slope, but it's the negation or the negative. So what we're going to look at is the unit rate remains constant. In other words, it's a straight line, so the proportion is somewhat constant. And then we should probably highlight, that's any 2 points on the line. So if I go down 4 over 3, down 4 over 3, I will always be on the line. So then it says, what is the slope? Well, if I go down 4 and over 3, that's how if I start here and I go down 1, 2, 3, 4, and I go over 3, that gives me my next point. I go down 4 over 3, that gives me my next point, and that's how we draw that graph. That's going down in the y direction is negative, going to the right is positive. So then my slope, m, is equal to negative 4 over 3. Because remember, your slope is the change in y over the change in x. Okay? Now it says, how do you do the graph? What would be the equation, right? So write the equation that represents their bus stop. Well, we know that it's going to be y equals negative 4/3 x. But we have to add that initial value of 30. Remember, this is what we call the initial value. They started at 30. This is also known as the y-intercept. This is the slope or rate of change. Okay? Last question, question number 4. It says, how does the equation you wrote represent Jack and Jill's home from the bus stop compared to the equation that represents their walk to the bus stop? So first thing I noticed, they have opposite slope. Because we're comparing two graphs, right? We're comparing y equals 4/3 x to y equals negative 4/3 x plus 30. The second equation has an initial value of 30. So the first equation doesn't have, it has an initial value of 0, right? So you could say the first equation has an initial value of 0. Now, the second one is somewhat translated up, but I like the way that I worded it a little better. So mathematically, we start at 0 when we're walking to the graph. I'm going to give you a second to write that down, then we'll look at the graphs, and then I'll explain it while we have the graph on the screen. So when I compare the two equations, I've got y equals 4/3 x, that's going to the bus stop, and then home, to home. The second equation going home, because you're already 30 yards away, you have an initial value of 30. Because you're walking home, the distance is decreasing because you're getting closer to the home, so that's negative slope. All right, so they have opposite slopes. And then the second equation has an initial value of 30 because that's where the bus drops you off, 30 yards away from the house. And the first equation has an initial value of 0 because you're leaving the house. You're 0 yards away from the house because you're leaving. So let me put this graph on here and we can talk about that. You're right here, you're 0 yards away from your house, and you're walking away from your house, but your initial value is 0. Here, you're away from the house, so your initial value is 30, and you're decreasing. And you're getting closer to your house.